Bismillahirrahmanirrahim. My name is Rashid, and this is the first step that I am working on, in which I am trying to move these motors using PWM signals. And here is the code. I will be changing this code as I add on further features. Right now I am using timer 0 and I am using Atmega 2560. And first of all, I have added some libraries, and this is the variable for motor speed, which can be changed. Right now I am using it as 255 since it is just basic, and I am checking it. As I will add more features, then it will be changed in the code. So this is the configuration for timer 0. And for fast PWM I have set WGM01 and WGM00 bits, and this is for interrupt. Right now I'm also not using this interrupt, but as I add further features I will be using it. And I am adding this motor speed variable into OCROA so that PWM is generated, which I will use to run the motors. This is the prescaler I am using, and I haven't added much. I've just added a delay, and this is just for the PWM mode. And here is my circuit. This was the circuit on which I checked if the PWM signal was working. It is working well. I can show you here. I have uploading same code on both projects. Here we can check the output signal. If I change the motor speed variable, then there will be a change in the PWM signal. Let's keep it 75 and build solution. And if I play it, I think I haven't uploaded code on this one. This was the project, yes, sorry. So here the motors run. Right now I am using logic states. As I complete the code, there will be pins from which the motors will receive their signal. Here the main thing is this motor speed, as I am using OCROA, and this is available on PB7 on Atmega 2560. So I've attached it here, and the motors are receiving the signal. 5 volt on these two pins and ground for these, and these are the 4 pins which I will be changing later. Right now I am just checking if the PWM mode is working. So it works like this, it goes right, and it is for opposite direction, and this also works. And if I change the code and keep it 0, then it won't work. As I am giving signal, but still the motors are not running, because the motor speed variable which is controlling their speed is 0 right now. So as I increase it, the speed of the motor will increase, these two motors which will be used as wheels, and as I decrease it, the speed of the motor will decrease. So this is first step, and I will record further as I add more features. Bismillahirrahmanirrahim. As I was working on my project, I have made some changes now. I haven't changed the code a lot, it's almost the same, but instead of uh, giving the motor speed PWM signal to enable pin, now I am giving it to this here, the pins which drive the motor, so I can control the speed of motor in this way. I can show you. In this way, the speed of the motor is 25 out of 255, Now I will change the code. Yes, and I make it, instead of 25 I make it 125. Now speed of the motor shall increase. There is a visible change in the speed of the motor. So instead of giving that signal to the enable pins, I am giving it to pin in 1 and in 3, and in this way I will control the speed of the motors, as I have to lower the speed of motor at sharp turns, and whenever there is obstacle in front of it, the speed of the motor shall increase gradually. So I will use this feature now, and I was thinking about using two different signals for both motors, so whenever I have to change the speed of one motor I can do it easily. For that I will have to use timer 1 or 2. I will do it in next step, and I shall add it.
Bismillahirrahmanirrahim. Since my previous recording, I have made some changes and let's review them. First of all, now I have three variables: motor speed left, motor speed right, and int I. That is an integer. So I am using left and right to control the speed of motors, and I am using integer I to save inputs from port C, which I have made input here. So port C is our input, and here let me show you these three. These three pins are inputs where I will be adding fisheye sensors later. Right now for simulation purpose I am using logic state, but these are the pins from which we will get signal from our IR sensors. So these three are the input pins, and after that I have declared four functions for forward, left, right, and stop. So using these inputs our motor will either go right, left, uh, or it will stop, or it will move forward. What I have done here is that when it moves forward the speed is maximum, but when it takes turns the speed is half. We can change that later depending on our needs, but right now I have done that, and I have used switch statement. So whenever there is an input, our switch statement will uh, tell our robot to move right, left, or forward, or stop depending on our inputs. So let's check it. Here are the simulations. So these are three inputs in which I will add the IR sensors later, and right now I'm using logic state. So whenever only one state goes high the motor will turn left slowly, but whenever all three are high it will move fast, and whenever either of the sensor goes 0 and only one sensor gives a signal either right or either left, the motor will take turns slowly. I could have used it to make this motor go anti-clockwise, but I don't think we need that since our speed is slow. But whenever both left and right go off but our center sensor gives us high, our motor will move forward, and when it also goes low then the motor stops. So I use switch statement. It was better than if else, since if else takes computational time a little more as compared to switch, and it is better use according to our project here. So I have done this, and we will make another video after our next change in next video I am thinking about adding the three IR sensors, but they won't have a lot of effect since we will be using logic states. So either I will add IR sensor or obstacle detector. Let's see. Bismillahirrahmanirrahim. I just checked the previous recordings and I didn't check the voice, so there is some disturbance in previous videos. I apologize for that. And now let's continue. So as I had mentioned in previous recording, I will be using two different pulses for different motors. So I have made changes in the code, and instead of one I am declaring two different variables, and the one will be used for first motor and the second will be used for the second motor. And I have also declared the ports as output. These two ports are for OCR0A and OCR2A. Let me show you here. Here, this is for OC2A and OC0A. These are basically for the timer 0 and timer 2. Instead of one timer, now I am using two timers, and I have used same configuration for first PWM, and I am not using the interrupt, so I have commented it in later. I program in later code I might be using this for something, and there's nothing else. I also have changed the prescaler. Instead of 1024 there is no prescaler now, so I have to change that in the comment. And there's nothing in the main code yet. I am just configuring the motors. Let me show you now. So I am configuring this one as 255 and this one is only 25, so that speed will be visible, the difference between both motors. And I am using let me show you here. I am using OCR0A for first motor and OCR2A for second motor. This is from timer 0 and this is from timer 2. Let's run the code. So it will be, see, this motor is running slower and this one is running faster. And in the previous simulation I was giving 5 volts to both these terminals, but now I am giving this one 12 volts and this one 5 volts. I have generated this through DC power input and this one is given, and instead of giving it on the enable pins I am giving them to the pins which drive the motors, and I am giving it constantly 5 volts. So I can use these in later code for turning my robot. Whenever there's a sharp turn the motor will run a little slowly. That depends on my code if I configure it, but the main reason behind this is whenever there's an obstacle in front of it and the motor will stop, and when the obstacle is removed the motor will start running, but the speed of the motor will increase gradually, which will drive the robot. So this is progress till now, and in the next simulation I will be using IR obstacle sensor, and let's see, I will make the recordings. Bismillahirrahmanirrahim. So since our last video I have added the three sensors, infrared sensors, so the robot can follow the line, and it's 12:23 a.m. I think I will be working all night on rest of the sensors. So let's check their pins. So I have connected pin PC0, PC1 and PC2 to the infrared sensors, and I have named them left, right and center. So it is easy to change in the simulation if we will be adding two more sensors, but it will work perfectly with three, but we can also use five sensors. Let's see. So both these are giving high, and when I put this one, so all three are high and it goes forward. And when I close this one, so only one motor will move like that. I think there is some delay. We will check that. So in short, I have added these sensors instead of giving the inputs high or low using logic states. I am using these infrared sensors. I haven't changed the code, I have just changed the simulations and pinouts. So let me explain the code a little. So it's all the same. I just have four functions for forward, stop, left and right, and I am taking the inputs on pin C, and I am saving the values from pin C in variable I, which I am using for switch case, and through which I am calling the functions so the robot moves. So as I add more sensors, I will be making videos. Bismillahirrahmanirrahim. Since my last video, I am working on obstacle sensor, but I am facing some errors as it is working on Uno, but on Mega it gives some garbage values. So I thought of taking a break, and during this time I have added two voltmeters next to the motors, so it is visible what change occurs in it when there is a change in path. So let's check that. So when middle sensor is high, the motors both move forward and the voltage is at maximum, so the motor moves with good speed. But when I switch on this sensor, the speed of the motor should lower and it should start moving towards left. So you can see that due to PWM mode, the voltage it is receiving is small, and that is why the motor is moving slowly. You can see that it takes little time because I have added delays. After that, both motors will run. You can see the speed, it is faster than previous. And if I switch on right, Bismillahirrahmanirrahim. As I had mentioned in my previous recording, I have switched from Mega to Uno, and the code is same, and I have just switched the inputs from fisheye sensors. It was previously on port C, now I am using them on port B. Let's see. As I switch on all three of them, both motors will run. There's a small delay, you can ignore that. Now they are both getting high pulse, so the duty cycle is 255, and when I switch off this one, then only one motor will run. There there's a small delay. Now only this motor is running as it has to move towards the right side. So you can see here yellow one is connected to this motor, so it is getting a duty cycle of 255, so it is high, while the other one is getting 0 pulse, so it works the same when I switch this one. You can see there's a difference when I switch on only this. The motor is going to run slowly as it moves towards the right side or left side, so it is getting only almost half duty cycle. It is, I think, 100. I haven't changed it to percentage, so I am giving it direct values, so I am giving it 100 out of 255. So whenever only one motor runs, the duty cycle will decrease, and in return the speed of motor will decrease. See that here as well. So here is the code for here. It is almost the same. I have declared two variables where I am saving the value for the PWM, and I have created four functions, and in main I have declared input and outputs, configured the timer 1 and timer 2 with prescaler and fast PWM, and after that I am using switch statement to call the functions. Now in the next step I will be adding the obstacle sensor. Bismillahirrahmanirrahim. As I had mentioned in my previous part, I was going to add ultrasonic sensor, so I have added ultrasonic sensor. So right now it is just displaying the distance, and I tried to add more features, but I was facing some errors, so I thought I should make a video first of it working, then I will be adding more features. Right now the only thing it is doing is just displaying that instance that I am controlling via this variable register here. As I decrease the resistance of this variable register, there is a difference in the distance that it will display. It is taking some time as I have added delay, but the feature which I want to add is, as there is a certain distance from the mobile robot to the obstacle, then some functions will be called. They will stop the mobile robot, and as the obstacle is removed, the robot will start running again. These functions will just control the speed of motors through PWM, but I was facing some errors as it was showing garbage values. So right now it is working with the motors, and it just displays the distance on LCD, and nothing else is called any function. But in next iteration I will try to either add some functions which will change the speed of the robot with respect to the obstacle, or I will be adding the temperature sensor. Bismillahirrahmanirrahim. So I tried to add some more features, but they were not working and it was exhausting, so I thought I should explain the code till the point where I have recorded the video, as I hadn't done that in previous part. So basically I have added some more libraries, and I have changed the frequency to 8 million, and I have added LCD library to display the values, and these two are the same variables. I have added some more variables for ultrasonic. Those are timer overflow variable and unsigned integer, and a string of value and a long for count and distance. First of all, in interrupt service routine for timer 1, I am increasing the value of timer overflow variable. These are the same functions which are used in the simple line follower, which are explained in previous iterations. In main function, I have changed the pin configurations for the motors as well, as it was not working on analog pins. So from analog pin 0, 1, 2, I have changed it to the port B, and I am using the LCD on those pins. So pin PB0, PB1 and PB2 are actually taking inputs from IR sensors, and these are for the PWM. For these are the same configurations which I have explained in previous iteration. These are the new ones. For PB4, PB5 are used for LCD, and PC0 to 3 are used for the data. These two are the enable and read write pin. This is the configuration of timer 1 for ultrasonic, which I am using to generate a signal and calculating its width to calculate the distance. I have enabled the overflow interrupt, and mode of operation is normal. Trigger pin for output, which is PD2 and PD1, and I have enabled global interrupts, which I had mentioned I will be using in later part. First of all, when LCD is initialized, it displays a Rashid, that's my name, and it is having inputs in pin B. I am using only these three pins only, as I had mentioned earlier. Here we are giving after these are the functions, switch functions which are running the motor after that. To display the distance, I am using this trigger pulse. I'm giving a trigger of 10 microseconds on this, and after that clearing timer, and I am configuring as rising edge and clearing the flag and timer overflow flag as well. And to calculate width, I have written this condition which is waiting for the rising edge, and after that I am clearing the timer and then capturing it on the falling edge, and I am clearing the flags. After that it waits for the falling edge now and saves all these values here and multiplying it with the speed of sound, so the distance is calculated. You can find it on the internet or you can write your own, but I will suggest you can find it on the internet easily, but it can change with the frequency of the oscillator, so keep that in mind. Bismillahirrahmanirrahim. In previous video I had added all these sensors besides temperature sensor, which I have added in the simulation just now, but there's an error. When I run this simulation, I get the warning that simulation is not running in real time due to excessive CPU load. I don't know why this is showing this error, but I try to run the temperature sensor alone separately on Uno, just only the pins which are connected to the temperature sensor. I have added them, and I haven't added any other sensor. And in the code I have also copied the code which is used for the temperature sensor only. uh, I will explain it a little, but I'm thinking about explaining the whole code in the end, so I won't go into details. I have used ADC4 for the low digital conversion, and the rest of these configurations are explained in the datasheet, which you can check. Nothing else is here besides this formula, which is used to convert the voltage into digital value, which is then saved in variable, and this is converted into string, so it is displayed on the LCD. And this mux is used to configure which ADC you are using. It is explained here. So for using 0, you have to set 0 bits to all muxes from 3 to 0, and I am using ADC4, so I am sending high bit to only mux 2, and this one is used to configure the reference voltage, which is with external capacitor in my case. Moreover, these are used for enabling the conversion and interrupts and for prescales, and it is working perfectly here. When I change the temperature, it also works, but I don't know why it's not working with the rest of the sensors. I will be trying to do it again from scratch. That is the only option because I have tried doing everything else. In the next video, either I will be working on UART or I will start it from the scratch, so the temperature sensor works here. Let's see. Bismillahirrahmanirrahim. So in this video I will try to summarize the whole project. So basically the task is to create a mobile robot that follows a black line using 3 IR sensors, and the speed of the motors is controlled using PWM, and the motors used are DC motors, and there is temperature sensor also included, which will display the temperature. And moreover, all of this needs to be done on a microcontroller, and the display is to be done on another microcontroller, and there should be serial communication between both, so it is displayed on another, but the values and configurations all are on another microcontroller. So how I've done is pretty simple. I have used two timers to control the speed of motors, timer 0 and timer 2, and I have added 3 IR sensors from where the values I take these values, and on the basis of these I have created 4 functions: forward, left, stop, and right, which are then called, and they control the speed of motors using PWM. After that, I have added obstacle sensor, and I am using variable resistor to change its value, and I am using interrupt 1 here and timer 1. Timer 1 is used in the temperature sensor, so all of these are then displayed on LCD. Here is the code. So first of all, these two variables are used for the PWM control of the motors, and these are for ultrasonic. And this, from here I have declared functions. First of all, there is the timer 1 overflow vector, which is used for interrupt service routine, in which it is incrementing the value of time overflow variable. After that, I have declared the function forward, in which speed of motors is maximum,
instead of using a percentage from 0 to 100, I am using duty cycle uh, from 0 to 255, as I am using timer 0 and 2. So it is maximum for forward, and for left it is 100. It can be changed easily. For right again it is 100. For moving it left and right, I am using only one motor or wheel. I could have used two wheels, in which one would have gone forward and another would gone backwards or clockwise and anti-clockwise. But for that, I needed four timers, and the code was going to be more complex since the job was being done using two only. So I prefer to stick to this. And on stop, both motors will stop. After that, I have declared inputs and outputs. These PB0, 1 and 2 are for fisheye IR sensors, which are declared as inputs, and for OC0A timer 0, I have declared PD6, and here's the configuration for timer 0 and timer 2. And for that, I am using fast PWM for both and prescaler of 1024, which can be easily checked from the datasheet. For a prescaler of 1024, you need to set the bits of CS00 and CS02 in the case of timer 0, and CS22 and CS20 in the case of timer 2, which I am doing here for timer 0 and here for timer 2. And these WGM 2120 and B1 for the fast PWM mode. After that, I am declaring pins for LCD. These are PB4, PB5. I was going to select all the pins from only one port, but as interrupts and timer pins are on different ports, so I could not do that. Instead, I chose PB4, PB5, and PC0, PC1, PC2, and PC3. These two are enable and read write bits, while these four are for the data bits. And after that, I have used timer 1 for ultrasonic, in which I am enabling the timer 1 overflow interrupt, and I'm using it in normal mode. And this is the trigger pin which I'm using on ultrasonic sensor. Let me show you here and here. So PD2, and I'm turning PD1 turn on pull up, which you can see in detail in the datasheet. After that, I am using the variable var for temperature sensor, and this to save the converted value, which is later then displayed. After that, we have add mux register, in which RE, FS0 and mux2 bits are high, which you can check from the datasheet as well. These are the four muxes from 0 to 3, which can be configured in different ways depending on which pin you are using. Since I'm using ADC4, so I have sent higher bit to mux 2. This was the code, yes, here. And and this one for the external capacitor, which is giving the value for a reference. After that, these are the bits which you need to enable conversion and interrupt, and again for the prescaler, depending if you want to use it or not. And this function is, sorry, used to enable the global interrupts. This, all of this is in the main code outside the loop. After that, my loop begins, in which first of all I am initializing the LCD and setting the cursor on 00 position and displaying my name with the delay of 250 milliseconds. After that, I am saving the values of first 3 bits from pin B in variable I, so I can use the switch. Switch is used for checking which orientation is the mobile robot in, so it can either move forward, stop, go left or right. In case of 000, in which all 3 bits are giving us 0, it will stop, and in this case when it is 001, since I've kept this one on the right side, so it will move right and then function is called. And in case of 010, it will move forward. Likewise, this is right, and let me show you. Yes, here I have kept this one in left. You can do them in different ways, but it is very easy to read them, so I've kept the third bit for left and first bit for right. So every time the loop begins, the values will be saved in I, and after that the switch will move the robot. So, and as I have mentioned the functions, the speed is controlled depending whether it is moving left, right or going forward. You can check that it is still in the while loop, as it's just getting out of the switch. You want to keep all of them in the loop so it works every time, otherwise the distances will be shown only once. After that, this is for the ultrasonic sensor, which displays the distance if there's a hurdle in its place. So you can see, once we send a pulse to trigger, we then later use it to calculate the distance, and for that we clear timer 1, and on the rising we have configured it to work on the rising edge, and after that we are clearing the flags and calculating it using this formula and setting the values in the variables which we have declared earlier. After that, it is displaying the distance with dist is equal to and the value which is saved here, and after that we will be displaying the temperature. After LCD is cleared, it says LCD displays T is equal to, and the values which we have taken on LDC4, they are converted, and this is the formula which converts the voltage into the value of temperature, and after that it is converted from this value which is in digits, it is converted into string using this function, and then it is displayed. So here ends the code, and every time this ends, it will go back to the first loop. And I think the problem here is we are not using a lot of interrupts, so there might be a little delay. If we had used interrupts for all of the functions, at least for the PWM control, then it would have been much smoother, and in my code it runs a little slow with some delay. So it would have been better if I had used it mega, and I was using it in the first, but I faced a lot of errors since we had worked on Uno the whole semester, so I switched back to Uno. Bismillahirrahmanirrahim. It is 4 a.m. and I'm still working on my project. So in the previous part I had already explained the code, but after that I have changed the code and I have created many functions, and Alhamdulillah the code is running very smoothly now, and the simulation is also working. So I will explain the code. I won't explain the things which I already have explained. I will just explain things which I have added. I just have created a lot of functions, so the code is simple, but that's what I feel. I think maybe it's more complex for others now. Since I have written this code, it's very easy for me to understand now better than before. So here, let's begin. First of all, these are the variables for motors. These are for Sonar, for LM35, and after that we have functions. So this function is to call switch, which is the first function we will use, so the motor runs, which will then call these functions. So this function actually calls another functions. After that we have timer 0, timer 2, and timer 1. These three functions are to configure timers. They only configure the timers, they do nothing else. After that, this one is for configuring the log to digital converter, and then we have functions for distance and temperature. This calculates the distance, and this function displays the distance. This function calculates the temperature, and this function displays the temperature. So it's quite simple now, because in main we have just we have to consider the input and output pins, and after that we will just call functions. So these are pins for IR sensor, these are for LCD, and these are for log to digital converter, which you can check in previous part. I have explained in detail. After that, in main function, first of all I am initializing the LCD, and then I am displaying my name. After that we are configuring timer 0 to 1 and log to digital converter. After that I am calling the switch function. Let me show you the switch function. Here is the definition of switch function. Switch functions just saves the value from IR sensors for first 3 bits, and then uses these to call different functions. If all of them are 0, it will call stop, and if rightmost bit is high, then it will call right, and likewise forward, left, and right. And I can also show the forward, left, and right. Forward will basically save 255 in both variables, and they will be in turn saved in OC2A and OC0A and OC2B. This is how the switch works. After switch we are calling the function to calculate the distance. Let's go to this definition. Yes, this one. Here we calculate the distance. It is explained in detail in previous code. After that we have the function which displays this distance, and then likewise temperature is calculated, and then temperature is displayed, and that is all in the main function. And then now it goes back, and I may need to take this out of the while loop where I am configuring this, but it won't affect our code a lot. There it won't make a lot of difference, but that is better coding. So this is how it works. In the next part I will be just adding UART in my simulation, and I will write the code for receiver, because transmitter's code will be all of it, and I will add a few more things. Bismillahirrahmanirrahim. In the previous code, I had used all sensors and one board, and now I have added another board and I'm trying to do serial interfacing. And I have added two LCDs. So the first one is from the previous microcontroller and it displays the values, and then it serially sends data to second microcontroller. It's named RxD, and it displays those values on RxD LCD. So I haven't done any changes in the simulation. It is the same. I've just added these two and their pins and connected both. And in the code I have written another code for TXD and RxD, those are transmitter and receiver. And in main function I haven't changed a lot. It is same. I've just called functions, and here are the functions, and I've added their definitions in the end. So the first function is to initialize UART, second one is to send character, the third one is to receive character, and the last one is to send string, which will use the first function in a loop. So the first function which initializes the UART is here. In this I have just added the baud rate, that is 9600. For that I have made its value 103. You can calculate it using a formula, and your oscillator frequency, you can change any of them. So according to your values you can change them easily in the simulations, but if you are going to do them practically, then you have to change the values according to your oscillator frequency. You can easily calculate them, and there are formulas for them given in the datasheet or any book. Here are the formulas to calculate baud rate. Depends on which mode you are using. If you have baud rate selected in your mind, or you have oscillator frequency, then you can calculate UBRR, or if you want to change baud rate, then you will change either your frequency or UBRR. In my case, the baud rate is 9600, so UBRR has a value of 103. After that, this is the register, and I am enabling transmission and receiving using these two bits. They are also in the datasheet, and you can use them if you can't memorize their names. It is not necessary to memorize your names. Datasheet is available. This is the bit that where is it, we use in the functions, but yes, here we are using third bit and fourth bit to receive enable and transmission enable. Here, and in functions we are using other bits. This is the code for transmitter. Rest of the code is almost same, which is changed, and there are a lot of functions, and main code is pretty simple. And here's the code for RxD. It is smaller than the TXD, and it is also much simpler, and you do not need a lot of libraries here. Only these three libraries are enough. And this is to UART, initialize UART. Same baud rate you need to keep in UART. If you have studied serial interfacing, you know that in UART baud rate is important for their communication. After that, I have initialized the bits, which you can check in the datasheet, and same functions, and I have just kept their name different, but it won't matter if even the names are same. But for simplicity and to understand the code easily, I have changed their names, and in main it receives function and displays it. So here is the simulation, and now it is not working and there are some errors. So it is all from my side. There can be mistakes and things might be not very clear in this video, as it was task and I had very strict deadline. It is 5 a.m. and I am still working and it's been almost 12 hours. So if still there are any questions, you can ask in the comments and I will try to answer them. Thank you very much.